Good morning. Welcome to, this is transitioning for me. Welcome to the 5.07 Appropriate Measures section. We have our Vision, Mission, and Class Connect Code of Conduct. But since we're not meeting, we don't really need to discuss any of that. So today we've got some learning targets. I can determine the most appropriate measures of center and spread for a set of data based on the shape of the distribution. So we're going to be talking about what's most appropriate using the mean versus the median, and then some other useful measures of center as well. And then we're also going to be looking at comparing two sets of data using box plots. So using those box and whisker plots, we're going to be comparing two sets of data at a time. Okay, so really quick, we're just going to do a quick refresher. We know how to find the mean, median, and mode. I'm not going to go through how to do that, but I'm just showing you the outcome here. So here's our set of data. We've got 2, 3, 3, 4, 5, 5, 6, and then the number 25. So if we look here at what we would determine, if you were to type all these in, you'd get 6.625 for your mean. Your median would be 4.5, and then your mode is the numbers 3 and 5. So when we're given a set of data, we can ask ourselves, okay, what is the best representation of the center of this data? Okay, is it more accurate to use the mean, or is it more accurate to use the median in this set of data? So let's talk about how we're going to determine that. So if we look at a dot plot, this is the same data set that we just talked about, same data set, but notice how they're plotted on this number line. So here's most of my data is occurring right here, and then I've got this guy all the way out over here. Notice when we have something that's skewed like this, so we have this guy, we're going to call him an outlier in a minute. We have this guy out here who's all alone, he's stranded by himself. Notice how the mean is being pulled towards that outlier. Where the median stays with the majority of the data that was given to us. Okay, so this outlier is a data value that is far from the data. An outlier in a data set will cause the mean to misrepresent. Okay, so the mean gives a false sense of what's happening to this data set. Okay, so in this case, we wouldn't want to use the mean because 25 doesn't really describe what's going on with the majority of the data. The median of 4.5 would be a much more accurate description of the majority of this data set. Okay, so notice here that all the data points are below the mean. So all of my numbers except 25 are below the mean. So that doesn't really make sense to use the mean to describe the data when, let's see, 7 out of my 8 points are below it. We want the mean or the median to describe the average or the middle of my data the best way possible. So the mean in this case is not accurate measure of center. The median would be much more representative of the center of data. So when we have this outlier out here, we are not going to use the mean. We're going to use the median, okay, to describe the center. Okay, so what about measures of central tendency? So these are other measures that we've talked about. Range, that's your max minus your min. Okay, you've got your interquartile range, that's your Q3 minus Q1, and then standard deviation was in that video that is being sent out that you're supposed to watch before this one. And standard deviation describes the average spread of the data. So how far the next point is away from the mean. Okay, so if we look here at this set, notice that the range, well, the range is describing that 25 all the way to the 2, which isn't really going to help us represent this data accurately if we're using the median. Okay, but notice that the interquartile range, look at that. Remember your median was about right here at 4.5? Looks like the interquartile range would give us a pretty accurate description of our central tendency. And then standard deviation, again, is outside of all of this data. So since it's outside of all that data, we're not going to use it. And standard deviation, the range, and the mean, all three of these items, they go together. So if you use the mean to describe the center of the data, you'd also use the standard deviation and the range if you have a symmetrical distribution. But when we have something that has an outlier or is skewed, we're going to use the median and the interquartile range to better represent that data. Okay, so just a little recap. Okay, is your data skewed or contains outliers? We're going to use the median and the IQR, those interquartile range. That's your Q3 minus your Q1. And that's going to give you an appropriate measure of your data. If it's uniform or bell-shaped, remember, here's your bell shape, or uniform would be something kind of like this, or it makes a rectangle. We're going to use the mean, standard deviation, and range as appropriate measures. So there's two different scenarios that you'll have to look for. Okay, if it's skewed or contains outliers, median, IQR. If it's uniform or bell-shaped, mean, standard deviation, and range. All right, so what about the mode? We didn't really include the mode in any of this. So the mode, the answer to this is it's sometimes used, just depending on the scenario. So if the mode is around the other appropriate measure of center, it can also be reported. So in this case, my mode was 3 and 5. My median was 4.5. So they're around the same. So it wouldn't necessarily be horrible here to use the mode to represent our measure of center. But a good example of this is, let's say, like you're talking about the average number of babies that people have in America. And let's say the average is 1.75, or the mean, not the mean, Mrs. Stanley, rein it in. Let's say that the median of having babies is 1.75. Okay, but you don't really have, obviously, 0.75 of a baby. You either have a baby or you don't. So using the mode here, let's say that the mode was 2, because it's the most frequent number that occurs, would be the best descriptor of our measure of center in this case, because it's referring to the actual raw data as opposed to the median, which was calculated. Okay. All right, so these next 5 questions we're going to go through are just like the 5 questions on your quiz. So this notes section it's your notes and it's your quiz review all in one. So those of you who have never watched a quiz review, this is kind of a good intro to what you would expect when I'm doing my quiz reviews. So we go through each of the 5 questions. You can pause after each question and then take it on your quiz, or just take your quiz at the end, however best suits you. So, oops, in this first question, it says that the data is calculated, or the data is, that's supposed to say calculated, calculated from wait times of 100 patients at Office 1. Okay, so there's 100 patients at Office 1, and there's 120 patients at Office 2. Now it says how many more patients saw the doctor in under 21 minutes at Office 2 than at Office 1. So let's take a look. Okay, here is our minutes. So right here, this is 21. So notice that Office 2, I'm going to label these. We want to know, okay, how many people waited in under 21 minutes at Office 2 versus Office 1. So Office 2, look at this, my maximum, remember this is your maximum, my maximum is 21. So that means every single person at Office 2 waited less than 21 minutes. So in Office 2, since there's 120 people, I'm going to use all 120 people because that was my max value. Now notice here where it's 21, this middle term, if you remember when we're labeling our box plots, this is your min, this is your first quartile, this is your median, your third quartile, and your max. Okay, so if I'm at my median, remember this is 50% of the way up, it's the middle point. So I need half of the people at office 2 are going to be less than 21 minutes. So there were a total of 100, but I only want half of them, or 50%. So if I write that as a decimal, 0.5, and that's going to give me 50 people. So I want to know how many more occurred at office 2 than office 1. So we're just going to go ahead and subtract those two numbers. So 120 minus 50, and we're going to end up with 70 more patients or people. Okay, and that will be your final answer. All right, so that takes care of question number 1. We're going to move on to question number 2. All right, so question 2 says the price of the last 8 used cars sold at a dealership are, and then it lists them all out. So there's 8 cars here, and we want to know which statement is true. All right, so you need to find the mean, and I'm actually going to do something here. I'm going to put the statistical representation is this X bar. So if you have a calculator, you'll see X bar, and in the next unit, we're going to use this a lot more as well, but just to kind of get you used to it. Okay, so X bar stands for the mean. Okay, so we need to find the mean, and we need to find the median, that middle number. Okay, so to do this, we can use our calculators. And let's see, that's not what I wanted to do. All right, I'm going to pull up my calc here. I'm going to go into data. I'm going to hit data twice so I can clear out that list. And then I'm going to go ahead and put in those values. So 11,400. And make sure, I would just double check as you're going through, make sure you're not typing things in wrong. 31,600, 23,600, 22,000, 11,100, 23,400, 69,700, and then 17,900. Okay, now those of you who do not have this calculator, go get one. But in the meantime, you can go ahead and just type all those numbers in and add them all together. So once you do that, add them together, that you'll divide by how many you have, and there's 8. I'm going to go ahead and go into hit second, and then that data will bring up the stats. Number 1 will bring up the 1 variable statistics. I'm using list 1, frequency 1, we'll hit calc, and there's my X bar, that number 2, there's my mean. Okay, so my mean, let me bring this over just a smidge. I don't think I can write that. Let me grab, oh, I have this written down. Okay, so I've got it written down. I'm going to pull this back up. Okay, and my mean, 26,337.5. Okay, and this is in dollars. Now, if you were to pull up your calculator again and you scroll down until you get to the median. So there's the median, 22,700. Okay, so there's my two values. Now, if you were doing this by hand, for those of you who don't have the calculator, to find the median, remember that you have to list the data in order and then find your middle number. Okay, so that's going to be how you find the median if you do it by hand, but for the sake of time, I'm just going to use the calculator. Okay, now look at the numbers we got. Notice how the mean is a lot bigger than the median. And notice if we look at this data, okay, so we had 11,000, 31, 23, 22, 11, 23. Then look at this. Notice this guy, he kind of sticks out like a sore thumb. Okay, then we've got one car that was sold for $69,700. That's a pretty expensive used car. Okay, so this guy is most likely an outlier. And notice how the mean average goes up quite a bit from the median or the middle number. Okay, there's a 4,000 difference because this 69,700, this car sale price totally inflated the average. But the median is going to be more accurate in this situation because it doesn't let this outlier impact this value. Okay, so because we have this guy that kind of sticks out like a sore thumb, this outlier here, the median is going to be our appropriate measure of center. Now, notice here how C says the median and the mode. Well, there is no mode for this data set. There's nothing that repeats, so we wouldn't use C. We would just use A. Okay? All right, so moving on to question number 3. So it says the dot plots show the gas and mileage in miles per gallon. Gall, that's supposed to say gallon, for several cars and SUVs. So here I have my SUVs, here I have my cars. It says to compare the median of gas mileage of SUVs to cars. Now you might be asking yourself, well, how am I going to find the median in a dot plot? Well, we can just kind of count inward. So these would kind of cancel each other out, and then I'm just going to kind of go through the list until I get to the middle. Okay, so there's my 4th one, here's my 5th one, and then I'm left with my middle number. Okay, so the median of my SUVs is going to be 20. So if I do the same thing for the cars, I'm going to cross these off as I go through. Cross out the 2nd one, this is my 3rd, my 4th, my 5th, and I'm left with that middle number. I'm left with 25. Okay, so there's my middle two values, 20 and 25. So if I'm comparing them, the median of cars is 5 miles per gallon greater than SUVs. Okay, so that's the first step. Now, some of you might be asked, instead of to compare the median, you might be asked to compare the mode. So we want to find the number that appears the most. I'm just going to change my pen color here. So notice in my SUVs, this 19 is what appears the most. So that's going to be my mode. And then in my cars, 26 appears the most. So that is my mode. So again, when we compare these, we can say that the mode of cars was 26 and SUVs was 19. So that's a difference of 7. So the mode of cars was 7 miles per gallon greater than SUVs. Okay, so we're just comparing those two. Okay, so we're going to move on to question number 4. It says biology students went on 2 field trips to identify insects. The box and whisker plots show how many insects each student was able to identify during the trip. So here's the first trip, here's the second trip. So during the first field trip, students typically identified about how many less insects than the second field trip. Okay, so a key here is when it says typically identified, this is talking about that middle value, your median. Okay, since we're talking about a box and whisker, that's our central, our measure of central tendency is going to be the median. So this is where we want to look. We want to look at the median in both of these box plots. And remember, the median is the line that's inside the box, because this is your min, this is your first quartile, that's your median, this is your third quartile, and this is your max. That's your 5 number summary that we talked about. So we're comparing the medians of the first field trip to the second field trip. Okay, so let's see how many less they identified. So in the first field trip, if I come down, it looks like this is 17 insects, as opposed to the second field trip, we're down here at 19. So we went from 17 minus 19 is going to give us 2. So it's 2 less insects than the second field trip. And notice the first field trip versus the second field trip. Notice in the first field trip, like there were some students, or maybe one, maybe more than one, but the minimum value was 2. But they learned a few things, obviously from the first to the second, because then the minimum value on that second trip was 15. So they did much better after they had some experience identifying those insects. Okay, so one more like this where we are comparing those 2 box plots. So it says a researcher collected wait times on a Monday morning at 2 eye doctors' offices. It's rounded to the nearest minute, and we want to know the box plots of the data, or the box plots of the data are shown. What we want to do is fill in these blanks. So the range of wait times at office 1 is about, this is going to be like how many minutes, less than or greater than the range of wait times at office 2. So we're comparing the wait times. If you remember, the range is your maximum minus your minimum. It's that entire spread of data. So if we look at Office 1, okay, Office 1, my maximum is at 30 minutes and my minimum is at 12 minutes. Okay, so that gives me a range of 18 minutes. Now if I look at Office 2, my maximum is at 21 minutes and my minimum is at 5 minutes. So that spread is 16 minutes. Okay, so there's my range of both. And I want to know Office 1 compared to Office 2. So if I subtract those times, 18 minus 16, I end up with 2 minutes. So it's about 2 minutes. And Office 1 is 18, and that's greater than 16. So I'm going to say 2 minutes greater than the range of wait times at Office 2. Okay, and you'll have like a drop-down selection for these two, but I just had to fill in the blanks for us for our purposes in the review. Okay, so that takes care of your quiz review and your notes for section 5.07. And really quick this week, so we just did appropriate measures. You're going to have a separate video for the second part of this lesson, which is on fences and outliers. You want to make sure that you still watch that, even though there's not a quiz over it. You still are responsible for that material for your test, which is already on Thursday this week. You do have a test Thursday. We'll have a fun review session, and then we're starting Unit 6 already on Friday. Remember that there is no razor grade Tuesday or Wednesday this week as we are in professional development. Hope that you all have a great couple days, and we will see you all again on Thursday morning.